Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a polynomial when you are given irrational zeros. So basically you can see that these are irrational because obviously I cannot simplify the square root of 3. That's going to give me an irrational value. Now, it's also very important to understand that how and where we get irrational zeros. So let's just pretend, I had a function here, f of x equals, let's say, x squared minus 3. Now, if I was going to find the zeros here, I would plug in 0 in for f of x, and then I'd have to go ahead and solve. Now, obviously, this is not going to be factorable, but I could use the square root method. And if I use the square root method here, I'd have 3. And 3 equals x squared. Now, to go ahead and solve, I take the square root of both sides. But remember, when you're introducing the square root to solve, you have to include plus or minus. So therefore, x equals plus or minus the square root of 3. So anytime you're solving and you're going to have an irrational zero or irrational solution, you're going to have the positive and the negative. For instance, let's just look at this. Let's look at a number we can take the square root of. Let's say the x squared of 4. If I take the square root to solve, I get x equals plus or minus 2. Because negative 2 times negative 2 gives you 4, and positive 2 times positive 2 gives you 4. So you have to include the plus or minus. Now, why is that important? Well, because for most of these, all the rest of the problems, I provided you with both of them. But if you're given a problem where they only give you one irrational root, it's important for you to understand that there is the conjugate there, the negative or the other positive, whatever it may be. So now we're just going to go ahead and follow our operations here to write the equation of the line. Now I simply am just going to take my zeros, and I'm going to set them equal to x. So I say x equals the square root of 3, and x equals negative square root of 3. Then the next thing I'm going to do is I'm going to set them equal to 0. So I'll subtract square root of 3 on both sides. Here, I'm going to have to add square root of 3 on both sides. And therefore, I have x minus the square root of 3 equals 0, and x plus the square root of 3 equals 0. Now, these are my two factors from the zero product property. So these two are since they both equal 0, then I can write them in factored form of x minus 3 times x plus the square root of 3 equals 0. However, we're not trying to figure out what they equal 0. That's already the solutions. If I had an equation like this, I would apply the zero product property and setting them both equal to 0. So it's just basically using the zero product property in reverse. However, I'm not trying to solve for 0. I'm trying to solve for f of x. So I'm going to replace 0 now with f of x, and then I'm going to apply FOIL. So multiply x times x, negative square root of 3 times square root of 3, square root of 3, and there. Let's write this down a little bit lower. So therefore, when I multiply x times x is x squared. X times square root of 3 is going to be a positive square root of 3x. X times negative square root of 3 is going to be a negative square root of 3x. And negative square root of 3 times positive square root of 3 is going to be a negative square root of 9. Now, I just wrote this out because I wanted to simplify it and show it to you. Obviously, you guys can see when you have here, I have a positive and negative of the same term. Those are going to add to 0. So we don't need to write it. And then the square root of 9 is going to be 3. So my final answer is f of x equals x squared minus 3, as the square root of 9 is 3. And there you go, ladies and gentlemen. That is your answer. And again, as we work through it, if you remember that first problem I wrote there, x squared minus 3 gave us those two zeros. OK, so you can see I don't really have as much room in here at all. So I'm going to just kind of skip through this a little bit closer and kind of write this in its factored form. So if I was going to set these all equal to 0 here, my factors are going to be f of x equals x plus 1, x plus the square root of 7, and x minus the square root of 7. All right? Now, basically, when you have more than one term, I always like multiplying my conjugates or my irrational first, because if you notice, these are always going to give you a difference of two squares, because your middle terms, you can see this is the difference of two squares factored out. These are the exact same expressions, except one's positive, one negative. So therefore, it's always going to give you a difference of two squares, which is basically going to be x squared, minus your radicand in here, because x times x is x squared. Square root of 7 times negative square root of 7 is going to be negative square root of 49, which is just negative 7. So therefore, I now will have x plus 1 times x squared minus 7. And again, I'm just kind of following along through my same process. And now I need to go ahead and multiply again. So now I can apply the FOIL method. Actually, you know what? Let's use a different method. Let's use the box method for this. So therefore, I'll just take 1 up here, and I'll take my other one over here. Multiply x squared times x is x cubed. X squared times 1 is x squared. X times negative 7 is negative 7x. And negative 7 times 1 is going to be a negative 7. You can see here they do not have any common terms. So my final answer is f of x equals x cubed plus x squared minus 7x minus 7. OK? So again, I kind of skipped some steps. I didn't show setting them equal to x, then writing them set equal to 0, then writing them as a factored form. I just immediately went into, you know what, f of x equals these factors multiplied by each other. But for this next one, I'll go ahead and do that. Basically, what the second steps you could have done here is just write them all equal to 0. Whew, it's like a lot, right? And then you set them all equal to 0, so all the factors are just going to be, if I was going to write these all as my factors, I would have x, I would have x equals 0, x minus 2 equals 0, x plus 2 equals 0, x minus the square root of 5 equals 0, and x plus the square root of 5 equals 0. Therefore, by using the reverse zero product property, I basically have x times x minus 2 times x plus 2 times x minus the square root of 5 times x plus the square root of 5. Now, you might be thinking this is going to be a crazy multiplication problem, right? Well, it's really not that bad, actually, because you notice here I'm multiplying these two, which is the difference in two squares, and I'm going to be multiplying these two, which is the difference in two squares. And what's nice, again, about the difference in two squares is you can just multiply the first term and the last term because the middle terms are always going to add to 0. So I will replace 0 with f of x, and I'll have x times this difference in two squares is x squared minus 4. This difference of two squares is going to be x squared minus 5. Now, I'll multiply my two binomials. Again, I'll use the box method to keep everything simple. So I have x squared minus 5 and x squared minus 4. You could obviously use FOIL. I just like using the box method. That gives me x to the 4th, negative 5x squared. This one gives me negative 4x squared, and this one gives me positive 20. So therefore, I have f of x equals x times x to the 4th. And what's nice about it is you can see these diagonals are like terms. So that's minus 9x squared plus 20. Then, now I'll use the distributive property to multiply that x. So now I got to multiply that x times all of my terms. So my final function is f of x equals x to the 5th minus 9x cubed plus 20x. Whew. All right. So now let's get into the last one. And this one usually gets a lot of students, so I am going to break this one down kind of step by step. So again, just like we did before, just like I did here, just like I did here, set your zeros equal to x. So x equals 1 plus the square root of 6. X equals 1 minus the square root of 6. Then, once you have them set equal to x, set them equal to 0. So I'm going to subtract 1 on both sides. I'm going to subtract the negative 6 on both sides. I'm going to subtract 1, subtract 1. I'm going to add square root of 6, add square root of 6. So by doing that, those obviously go to 0, those go to 0. That goes to 0, that goes to 0. So I'm left with x minus 1 minus the square root of 6 equals 0. Over here, I have x minus 1 plus the square root of 6 equals 0. Since those are my two factors, I can write them as factored form equal to 0. So I could say 0 equals x minus 1 minus the square root of 6 times x minus 1 plus the square root of 6. Now, this is where it gets confusing for a lot of students, because basically what you can do, ladies and gentlemen, is you can apply distributive property here. It's a trinomial times another trinomial. Go ahead and have fun with it. I just don't see it being very much fun doing a problem like that. So another way I like to teach it is by grouping the first two terms. You can now see, by grouping those first two terms, I have now created a difference of two squares. I have my group terms, my first two terms are the same. My last two terms are the same, and it's positive, and it's negative, and it's positive. Therefore, by multiplying this out, I basically get x minus 1 squared And then negative square root of 6 times negative square root of 6 is going to be a negative 6. Now, please make sure you understand that x minus 1 squared is x minus 1 times x minus 1. All right, you could apply FOIL here, or the box method, first term, last term, middle, outside. However, for time, I'm just going to replace the 0 with f of x. I'm going to multiply this out in my head. X squared is going to be minus 2x plus 1. And then minus 6. Then I just add my 1 and my negative 6. So my final answer is f of x equals x squared minus 2x minus 5. So there you go, ladies and gentlemen. That is how you write the equation of a polynomial when given irrational zeros. Thanks.